Okay, question number 11, May, June 2024. Pure one. Let's get started here. Thread. First of all, here we have a figure. It's clear that it's sine. It started from 0, it's sine. If it started from 1, it's cosine. If it's like this and this, it's tan. So this is a sine questions, okay? And he gave you this is have an equation of 12 sine x. As usual, we have to draw in anywhere the original sine. Okay. By the way, here he wants you to find the coordinate of P. Here we have a point P, and he wants you to find the coordinate of it. Okay, let's see. And this is here. You're going to see it. Okay. First of all, here we have the original sine here. Graph. Normal graph here. Without negative, just the positive part. And here started from 0, go up. Here it's 0, and like a simple wave like this, and so on. Okay, so here normally is by radian. Let's make sure it's by radian. So here it will be pi over 2, then pi, then 3 out of 2 pi. You know it, 3 out of 2 pi, and here is 2 pi. Okay. And what is the equation? The equation is y equal to sine theta. Or let's make it sine x as he gave it to you. Okay, how about this? This graph, he said to you that this is y here equal to 12 sine. And here we have the 0, and here here is 12 sine x. You know, this is the amplitude, here the 12s here. So here we have a standard because it is cut it into like a symmetrical line. The same two parts here are equal. As you see, this port is equal to the down port here. So that is here will be 12, the maximum on y-axis, and the minimum will be negative 12. Okay. Anything else? Nothing else. Normal pi over 2 pi, 3 out of 2 pi, 2 pi, and here it will be 5 over 2 pi normally, okay, which is in degree, it will be 450, but you need it in region. So the point P here, it will be 5 over 2 pi, 5 pi over 2, and here it have a coordinate of 12. And no plus, no minus here. So as is with, we're not going to go right or left or anything. Okay, let's see the next. The next part of this question, he gave you curve 2. He gave you curve 2, and he said it has an equation of y equals sine x plus k. Back to our original sine equation, which is here is it, the original one. And he said to you, it has 12 sine x plus k. But he gave you a simple info and say the maximum value of curve 2 of y is 3. So this point is 3. How you can get it 3? Because this must be, let's draw another graph. Let's give the original beside us and draw the normal one here. Okay, so he said to you that this is 3. So we have a new axis. We have a new axis. If here is 12, if here is 12, so it is above the new axis with 3. Here, it must be above the new axis. I'll make it down because this must be in the negative part because we need to go up 12. And here, the maximum point must be 3. So here we have to get down. So here is 0. We get down here. We get down for 3. And we have to get another down for more 9, just to keep it 12. To go up 12. So here is the new axis started. Here, a new axis started to blow up and get down, blow up, then get down and complete. So here we have the 0. The origin here, and here I have to complete this now because this is the y coordinate and this is the x coordinate, and this is the maximum point. As he said, that is the maximum point is for this curve is right. Okay, what he want here, he needed the minimum point, so it's clear that we have to get down for another 12. This part is already I have drawn it. We have to get it minus 12 again. Okay, because this part must be equal to this part symmetrical. So if we go up for 12, here, if you go up for 12, we have to get down for another 12 from the new axis, this from negative 9. So here we have to get down for another, from negative 9, we have to get down for another negative minus 12. Okay, so let's try this. So normally here, minus 9, minus 12, it will be negative 21. And here, normally it hasn't been shifted right or left. here. So here is pi over, here is normally pi over 2, normally pi, and this is the minimum point that he wanted. This is the point that he wanted, which is 3 out of 2 pi on the x-axis. And on the y-axis, it will be, we have get it down to -12, so this point will be -21. How I get it? -12 minus 9 give us -21. So here we can write it. The new point here, or the minimum point here, is equal to 3 out of 2 pi on the x-axis, and on the y-axis is -21. Okay. That's great. Okay, curve 3. The curve 3 or C3 has an equation of y equals sine x plus b. So this has been shifted to the left, okay, or to the right. We're going to see. I think it'll be to the left here. So giving this pi over 4 and a, where a is a constant, is the minimum point on the curve, which has the smallest positive x coordinate. Find the value of a. Okay, we can substitute. Normally substitution, we can say instead of y, here he give you y, you can make it a equal. He said that's y equal 12 sine x, which is pi over 4. He gives to you pi over 4 plus b. Okay. And as you know, that's he gives it this is a minimum point, and the minimum point, the sine x of the minimum point is equal to -1, or the sine theta itself. So the whole sine pi over 4 plus b is equal to -1, and this is a minimum point rule. Okay, this is a common rule. Okay, so here we can kick all of these and put instead of it 12 multiplied by -1, which equal to -12, and we get the value of a, which will be equal to -12. And here find the smallest possible for b. And b here we can get it from this rule. So -1, normally it will be the angle 270. Right? You can calculate in your calculator. So sine 270. Let's make it with numbers and change it into pi over 4, which is in degree 45, plus b. So it must be equal to sine 270 here, which equal to here sine 270. So b here will be equal to 225. We're going to keep this. So b here, normally it's a number equal to 2 to 5 divided by 180 divided in 5. So it will be equal here to, after dividing by 180, here, so this would be equal to 5 over 4 pi. We get it. Very easy question. This is easy question.